All right, good people. So the first couple weeks of trig, we have been focusing exclusively with right angles, right triangles. How to find the ratios, how to find missing angles, how to find missing sides. That's what we've been working with. So now we're going to look at trig as it relates to a circle, going around the circle. So in order for us to do trig going around the circle, we first have to learn how to work with angles going around the circle. So we're going to start with identifying an angle. So if we put an angle on a graph, the start of the angle, which is called the initial side, so you have the initial side to an angle. The initial side is where the angle starts. So your initial side is always on the x-axis. The other side is called the terminal side. It marks where the angle ends. And of course, the angle is the part in between. So how you measure an angle depends on what direction you went. So if you think of it as a clock, so think of this as a clock. So if you are looking at a standard clock, you have 12, 6, 3, 9. So your angle starts at 3 o'clock. If you're going backwards, that's counterclockwise. So anytime you go counterclockwise, your angle is positive. So if you're going counterclockwise, that's for a positive angle. So 0, 90, 180, 270, 360. You go all the way around a circle, that's 360 degrees. So that means if you have angles that are bigger than 360, that just means you're going around a circle more than once. So if you were to go around a circle more than once, that would be 360 plus 90, which is 450. 450 plus 90, which is 540. 540 plus 90, 630. 630 plus 90, 720. So if you have to draw an angle that is more than 360 degrees, we can do that. And we will do that shortly. So the opposite is clockwise. Those are for negative angles. Clockwise is negative angles. So, if you start at 0 degrees, you always start at 0 degrees. Always start at 0 degrees. So clockwise is starting going down. So that's negative 90 degrees, negative 180, negative 270. You should make it all the way around, negative 360. So, if it's a positive angle, you start on the x-axis and you go up. If it's a negative angle, you start on the x-axis and you go down. It just depends on which way you need to go. So, before we do some examples, pause and answer any questions that you have before we continue. Again, closed mouths don't get fed. If you have a question and you don't ask, then that's your fault. It's no longer my fault. So Yes, technically that's wrong. Negative 50 degrees means you go that way. So you're stuck. You always start from the positive x-axis. So again, those of you at home, if you have questions, please make sure you ask. So, example 1. Draw an angle with the given measure. So we're going to draw a 240-degree angle. 240-degree angle. So the first thing that gets drawn is the first part of the angle, the initial side on the positive x-axis. Your initial side is on the positive x-axis. That always goes there. That never changes. That always goes there. So your initial side goes where 0 degrees is. So please do not change it, because changing it from that is wrong. You always start there. Now, 240 degrees. That's a positive angle. It's positive. So since it's positive, you're going to go counterclockwise. You're going to go in that direction. So anytime you come to the black bar, that's 90 degrees. So 0, 90, 180, 270. So 270 is too big. So we're going to be somewhere between 180 and 270. So you put your angle in. And then you draw a curve to indicate which direction you went. So you have to put that curve to let me know that you went in that direction. If you don't put that curve, then I don't know which way you went. If you don't put that curve, I don't know which way you went. And I'm not going to try to guess what you were thinking. I'm just going to mark it wrong. That's it. I'm good. Drew the angle. That wasn't that bad. Any questions? Example 1. Again, if you're at home, don't be quiet because you're at home. I don't care nothing that you're at home. You're still in school. You're still in class. If you don't understand something, you ask a question. Doesn't matter to me that you're at home. If it's loud in your background, type the question in the chat. Or I'll keep going, picking off all the excuses that you want to give me. You don't understand something, ask a question. If you do understand it, then show it to me in the IXL, show it to me on the quiz, show it to me on the test. All right, example 2. 500 degrees. So again, we have another positive angle. So we're going to solve it the same way. The initial side goes on the positive x-axis. That never changes. Put it somewhere else, just mark it wrong for me too. Because that's what I'm going to do. It'll save me some time. So that's your initial side. So 500 degrees means you're 90, 180, 270, 360. Okay. We're not at 500 yet. So that means we have to keep going. So 360 plus another 90 is 450. Still not enough. 450 plus another 90 gives you 540. Now that's too big. So 500 degrees would be somewhere in there. in order to get to 500, you had to go around the circle once. So you're going to go around the circle once, and then put the rest of the curve to get to your angle. Put the rest of the curve to get to your angle. So again, you have to put the spiral, which let me highlight that part. You have to put the spiral so that I know which direction you're going. If you don't put the spiral, then you're leaving it for me to guess. I'm not going to guess. I'm going to mark it wrong. So I'm telling you in advance what I'm not going to do. I'm not going to try to guess what you were thinking. Any questions on A or B? Before we do an example of a negative angle. Straight over there. Make sure your angles look like my angles. All right, part C. Negative 50 degrees. So, the negative angle. So, negative angles start out the same way. On the positive x-axis. So, our initial side is on the positive x-axis. So, negative, we curve down. So 0, the first line would be negative 90 degrees. So that's already too big. So negative 50 is going to be somewhere up in there. I don't need it to be exact. You don't need to go get a protractor or anything like that. You're drawing a sketch. So you have the angle. You put the direction that you went. So your direction is that you curve down. So that's it. Problem over. Yeah, it's not a hard problem. It's not a hard problem. You start to know what you're doing. Any questions drawing the angles before we continue? Any question on drawing our angles? So if we look at the homework that's due on Friday, this matches up with IXL X3, drawing angles. So this matches up with X3. IXL X3, drawing angles. So it gives you a reference. So, next concept. Next concept is an idea of what's called a coterminal angle. Coterminal angles. Coterminal is another name for the same angle. Angles ending in the same place. Angles ending in the same place. So, for this type of problem, to find a coterminal angle, you only need to know how to do two things. Add and subtract. You only need to know how to do those two things. If you do those two things, then you'll be in great shape. So, find one positive angle and one negative angle that are coterminal with each example. So one positive angle, one negative angle. So that means you need one positive answer and one negative answer. So coterminals. So to find coterminal angles, so I would make sure you write this down. Coterminal angles, you're either going to add or subtract 360 degrees, depending on what you need. Add or subtract. So for negative 45 degrees, to get a positive coterminal, so to get your positive coterminal angle, you take the angle that they gave you, and you add 360. The angle that they gave you, add 360. Stay focused, move there, Mahalia. Take the angle that they gave you, add 360. Do that, you get 315 degrees. So that's your positive. So that's your answer, the positive angle. To get the negative coterminal, you take the angle that they gave you and you subtract 360. The angle that they gave you, you subtract 360. So negative 45 minus 360 is negative 405 degrees. There's your negative angle. That's it. I'm over. Will, I hope you over there taking your notes. Fernando, Martin, Maggie, Shay, I hope you over there taking your notes. So that we can have some good work output when you submit this work to me. Any questions before we continue? So again, you need one positive answer, you need one negative answer that is different from the number that you started with. One positive, one negative that is different from the number that you started with. Has to be different than the number that you started with. So let's do one more example. We've got 395 degrees. We need one positive and we need one negative. So positive coterminal angle. So get the positive one, that's easy. Take the angle that they gave you and add 60. Take the angle that they gave you and add 360. So Sterling, I see you just added 360. What'd you get? 755. 755. So we got our positive one out the way. Now we switch it up. Negative. We do 395 minus 360. 395 minus 360 is 35 degrees. Is that negative? No. That's not negative. So since it's not negative, that means we gotta subtract 360 again. Again, if you don't get a negative answer, then you're not done. So if you subtracted 360 and said, okay, I'm straight. No, you're not. Because it's not a negative answer. So do it again. That's negative 325 degrees. Now you are finished. Now you are finished. So you need one positive answer, one negative answer. One positive, one negative. If that means you got to do it multiple times, then that is what it is. Any questions on coterminal angles? So once again, if I'm thinking about the IXLs that are due on Friday, this lines up with X5. So this lines up with the IXLs X5. These are in the Algebra 2 category, by the way. These are in the Algebra 2 category. I'll send you a reminder. I'm going to post it to Google Classroom. These are in the Algebra 2 category. Not Algebra 1, Algebra 2. So we learned how to draw these angles. We learned how to find angles that would land in the same place. So the last thing that we're going to do is look at how to convert angles. So the three parts in this section, this is the most important. Learning how to change an angle from degrees to radians. How to change an angle from degrees to radians. So it's a simple mathematical formula, changing from degrees to radians. So something in degrees is going to be some number with a degree symbol. Radians is going to be some number with the word radians in it, or it's going to have pi in the front. So the question is, how do you change back and forth between the two? So we're going to start with changing from degrees to radians. So we're going to start with degrees to radians. This part here. So to change from degrees to radians, we multiply the degree measure by pi over 180. So you're going to take the angle, multiply it times pi over 180. Now for degrees to radians, your answer must be in a fraction form. No decimals. No decimals with degrees to radians. So let's do part A. So part A will be done in blue so that you can keep track of it related. So 125 degrees. We want to know what it's going to be in radians. So this is how we solve the problem. Take the 125, put it over 1, so that's a fraction. Then multiply times pi over 180. Once you have it set up, now you multiply straight across. Now you multiply straight across. So that's straight from left to right. So left to right, left to right. 125 times pi is 125 pi. 1 times 180 is 180. Any questions before you finish the problem? It's not done. Any questions, sir? So you must reduce this fraction. If you leave this like that, I'm going to mark it wrong. You leave it like that on IXL, it's going to mark it wrong. So for those of you with scientific or graphing calculators, the calculator will reduce it for you. So for those of you with a scientific or graphing calculator, reduce it. So here's my graphing calculator. So in your calculator, we're going to type in everything but the pi. We're not going to type in pi, just the 125 and just the 180. So 125 divided by 180. Then go to the button in the third row. It says math. First button at the top says fraction. So press enter. And press enter again. And notice that it reduced the fraction for you. 25 over 36. So your answer is 25 pi over 36. $25 pi over 36. Any questions on that first example? We're going to do a second example of it, except I'm not going to go as slow. It's our second time through it. So, second example we're going to do, 135 degrees. Same rules apply. So we're going to take 135, figure out what is it in radians. What is it in radians? So take 135, put it over 1, times pi over 180. Multiply straight across. 135 times pi is 135 pi. 1 times 180 is 180. So now you reduce. Now, unfortunately, if you don't have a calculator to use, then if you don't have a scientific or graphic calculator, then you got to reduce it by hand. I mean, I can't go and buy you a calculator, so that kind of is what it is. So 135 over 180, go to our calculator. 135 divided by 180. Go to math, fraction, hit enter. You should have 3/4. So your answer is 3 pi. So, any questions changing from degrees to radians? There's another 30 seconds if you need to. Finish copying down that problem. We're going to go from radians to degrees. So now let's do it the other way around. So if we're going to go the other way around, going from radians to degrees, you take the angle and multiply it times 180 over pi. So now when you go to 180 over pi, you just flip in the fraction. So if you're going from radians to degrees, that can either be in whole number or decimal form. That one can be as whole number or decimal. That one doesn't have to be as a fraction. So let's do two examples of going from radians to degrees. So part B. Part B. You have negative pi over 12 radians, and you want to know how much is this in degrees? How much is this in degrees? So you take negative pi over 12 and multiply it times 180 over pi. So, just like the last time, you're still going to multiply straight across. Still going to multiply straight across. So it's negative 180 pi over 12 pi. So notice that there's a pi at the top and at the bottom. So pi cancel out. Pi cancels out. So that's negative 180 over 12. It should give you negative 15, but I'm not going to guess. Negative 15 here. Not hard if you know what you're doing. Any questions on part B before we do one more example? We're going to do one more example of going from radians to degrees. It's okay. Well, they're your notes, so as long as you know where they are. So, last example that we're going to do. So number 6 is just like number 5. We're going to do number 7. And that's just like the problem we just did up above. So we have 5 pi over 4. So you have 5 pi over 4 radians going to change to degrees. So this is just like the problem we just finished. So 5 pi over 4 times 180 over pi. Again, we multiply from left to right. 5 pi times 180 is 900 pi. 4 times pi is 4 pi. So the pi's cancel out. And we'll let the calculator do its work. 225 degrees. So we're 25 degrees. So again, ladies and gentlemen, they're not difficult problems. They're just problems that require a little bit of work. Any questions on going from radians to degrees? So this falls in line with IXL X1. IXL X1. No. So question 8 is pi over 10. So that's in radians. So anytime the pi symbol is already in the problem, that's radians. So that means the direction said convert the degree measure from radians to degrees, or degrees to radians. You're going to change that to degrees. Then that would be pi over 10 times 180 over pi. So 180 pi over 10 pi. That's 180 over 10, 18 degrees. So there's one specific type of problem that you might come across in your IXL, especially for those people who are trying to go for the extra credit, which I hope is everybody, because there's a lot of grades that need to be fixed real quickly. So here's our extra example. So in your case, Sterling, you can put it on the back of your notes page. So extra example. Find the positive and the negative coterminal angle for 4 pi over 5. So remember, coterminal means you have to add or subtract 360 degrees. But this is not degrees. This is radians. We can't add a radian to a degree. We can't add a degree to a radian. They either both have to be degrees or they both have to be radians. They either both have to be degrees or both have to be radians. You can't mix and match. So, if you can't mix and match like that, this is how we go about solving the problem. So they gave us the angle 4 pi over 5. This was given to us. We're going to change it to degrees. We're going to change that angle to degrees. So to change it to degrees, we multiply the top and the bottom. Well, so we multiply the bottom. 180 over 5. Multiply by 180 over 5. So 4 pi times 180 is 720 pi. 5 times 5 is 5 pi. The pi's cancel out. 720 divided by 5 is, I believe, 144. But let me check. 144. So what we did, we changed radians to degrees. Now the angle is in degrees. Any questions so far? Any questions so far? So we've got degrees and degrees. So now we can add and subtract. Now we can do some adding and subtracting. So now we can take 144 and add through 60, which should give us 144 plus 360 is 504 degrees. So that's your positive coterminal angle. That's your positive coterminal angle. And then 144 minus 360, negative 216. That's your negative coterminal angle. So we'll use the coterminal angle. So it's a problem that puts it all together. It's a problem that puts it all together. Of course, if we wanted to graph it, we can always graph it. 144 degrees. Your initial angle always starts on the positive x-axis. Since it's positive, you're going counterclockwise. 90 degrees, 180 degrees, so 144 will be somewhere in there. So in that problem, we did all three things that we learned today in class. Now, coterminals change from radians to degrees, and radian. You got yourself a little bit of a taste of all three parts. Any questions before we wrap up class? If you're taking notes, paying attention, asking questions, etc., then you should be able to do fine. If not, then it is what it is. But you can always come into asynchronous for additional help as well. That